Okay, so now welcome back. And for B, let's see, we would have 5 times x times y minus x times y plus x times x. So in other words, I've expanded everything out to clearly see what's common in all of these terms. And we see there's an x common in each term and a y. Oh no, actually, not a y. Hope someone caught that. Not a y, just an x that's common in each term, right? Just one x too, because although these two have two x's, it has to be common in every term. So the only thing that's going to be factored out here is x. And what are we left with? Well, in the first term, we're left with 5xy squared, right? So 5xy squared minus, in the second term, we're left with just a y. And in the third term, we're left with the x. And of course, we can check our answer by distributing this back in. And if we distribute that back in, multiply that x by each term, we're going to get 5x squared y squared minus xy plus x squared, which is our original problem. So we did that correctly. Okay. Now here, although I said you can factor into primes here, if you see the common factor that's in each term, so 18, of course we can factor 18 as 6 times 3, 18 times 1, but you want to look to see if there's a common term in each, and in this case it's 9, so we can factor that 18 9 times 2. That 9 is common in both terms, so we pull out that 9, and we're left with, in parentheses, x plus 2. And I'll leave it for you all to check that answer. Okay, now this is what's called difference of squares. And with difference of squares, note that we have, it needs to be in the square form, x squared minus y squared. When you get it in that form, then the way it factors is just x plus y, the quantity x plus y times the quantity x minus y. So one suggestion that I have when you're looking for difference of squares, you see how this x is already in that form, x squared, right? But this 4, it's not necessarily something squared. You want to rewrite, you can rewrite this as, well, 4 we know we can rewrite as 2 squared. So now you can clearly see that, oh, this is representing my y, that y squared in the formula. And so y in this case is going to be 2, right? So our answer in terms of factoring x squared minus 4 is going to be x minus, or x plus 2 times the quantity x plus 2 times the quantity x minus 2. It could go the other way around too. I usually write it x minus 2 times x plus 2, but since I wrote it like this in your notes, I'll stay consistent. And again, you could check to make sure your answer is correct. I'll leave that for you all to check that. And go ahead and see if you can rewrite B and C as well and come back and check your answer. Okay, welcome back. You see here, I rewrote that 1 as just 1 squared so I can have that form. And so the answer is x plus 1 times the quantity x plus 1 times the quantity x minus 1. And you really don't need that parentheses there. You could have just written it as x squared minus 1 squared. That's fine too. And so for C, m squared minus 5 squared. And so the answer is m plus 5 times m minus 5. Okay, here, now guessing. Now we're going to find a different way for these types of problems here. But for now, you want to try to guess, well, what can I guess to figure this out? And for this one, it might take you a minute. It's not necessarily straightforward unless you remember how to factor these. But this one will be x plus 3 times x plus 2. And you can check. And let me check real quick since we're wrapping up this video and the notes. Remember, we talked about this, I believe, early in the last class. Take each term of the first and multiply by each term of the second. So x times x is going to give us x squared. X times 2 is going to give us 2x. 3 times x is going to give us 3x. And 3 times 2 is going to give us 6. We have those common terms, so we get x squared plus 5x plus 6. Again, we'll learn how to do this more algebraically, more formally, but for now, you just want to sort of play around and guess. And then here, factor completely, again, how I did it earlier will be beneficial. So I'm going to write that as s times t times t times t plus 5 times s times t. And let's see, we have an s in common and we have a t in common. So we're going to pull out an s times t, or st. And we're going to be left with, in the first term, t squared. And in the second term, just a 5, right? Okay. And I want to do, so add this because I wanted to give you an example of what I meant with my comment earlier. Let's say, and if you want to call this example 7, you can. I'm just going to slightly change example 6. Let's say this was 5st cubed plus 5st. Now, with that same setup, 5 times s, and this video is a little bit longer, but we're wrapping this up, plus 5 times s times t. Okay. Well, there's a 5 common in each term. There's a s, right? And there's a t. This is what I'm talking about because 5st will be on the outside, and then we're left with t squared. And a common error that I see from students is they just leave the final answer like that. However, when you go back to check, your answer would be incorrect, right? Because you would only have one term. Remember, this is where, there's always a times 1. You always can put times 1 on each term if needed. And so really, there's still a 1 there. And that, when you check your answer, you'll get back the original problem. So I just wanted to show you that example in case you saw that in your homework or in a quiz or an exam. All right, we are done with this section of notes. I will see you in class.